Okay, so this is being recorded, just letting y'all know. All right, so what we're going to talk about today is solving log problems to where there's only a log on one side. In other words, both sides don't have log on them, just one side. All right, so number one, first thing you're going to do is check to see if you can simplify the log itself. By that I mean the argument and the base are both numbers. So if I have log base 2, 128, I can go do that in my calculator over here. So you can do it in your calculator or you can do it in Desmos. Okay, so log base 2, 128. And then it tells you right there is 7. Nope. All right, so then I would come back over here, and if there was an x right there, I would say 7 equals x. So there's my answer, x equals 7. Okay? All right, now what if, okay, so there we go. What if we have something else like this? Log base 3x equals 5. Log base 3x equals 5 right there. What we're saying now is I can't get log base 3x to a single number because I can't put an x over here in Desmos right there. That's not going to help me a whole lot. Okay? It's going to be like, okay, and what next? So you're going to have to actually use some of your properties. So for this one, we can tippy tails. 3 to the 5th power, keep grabbing, equals x. So we're going to tippy tails it. 3 to the 5th power equals x. Now I can do that. 3 to the 5th power, I just do that in my calculator. Or you can say 3 times 3 times 3 times 3 times 3. Ta-da! And that's your answer. Easy breezy. Hey, you're like, Mills, it can't be this easy. You are so right. It's not always going to be that easy. Let's look. Hey, sometimes right here, instead of just an x, it might be parentheses, 2x plus 3. So then you would say 3 to the 5th equals 2x plus 3. You can do that. You can solve it. Ta-da. All right, example 2. Now, let's look at this one right here. We know by our property of logs, the fact that this 2 is in front of that log, it actually means that it's the exponent of the argument that's in the parentheses right there. Looking at me using these big, huge words. These big words. Okay, so what they're saying is the argument means it's the 4x right there. That's the argument of the log. This 2, we used our property of logs, and we know that that 2 used to be up here as the exponent. All right, but they moved it down in front. Now this is kind of like isolating an absolute value. If there's something out front of it or something like plus blah, blah, blah out here, you move everything over to the other side. You're isolating the log function. So for this one, I'm going to divide both sides by 2. All right, I'm going to divide both sides by 2. So that gives me the log 4x equals 3. Now I cannot divide by 4 because that's inside that argument. It's right there next to the log, to the right of it. So you can't do that. So from here, I got a log on one side. I can't simplify it. So I'm going to tippy tails. Log on one side, can't simplify, tippy tails. Wait. There's no base right there. What do I do? Hey, you know what? It's understood to be a base 10. So if there is no base, it's understood to be a base 10. All right. So that's what we're going to do. We're going to say 10 to the 3rd power equals 4x. 10 to the 3rd power equals 4x. Now that's just a 1 with 3 zeros out the back. So we're saying 1,000 equals 4x. Divide button and just solve like normal. Divide both sides by 4. because now I can, the log's not there, and just keep going. Okay? All right, I'm not going to get to example 3 with you guys. I'm not going to do that yet. These are the kind that we're mainly doing first, all right? So I'm going to come into Alex, and I'm going to just look at a couple of them for you. Do one together. Y'all might want to do it on your piece of paper just in case you get the same one that I'm putting up there. Just so you know. Okay, so this one right here, we can rewrite it as a log, and this one we can rewrite it. Wait a minute, this one write it as exponential, this one write it as a log equation. Okay, I'm coming through and I'm going to look. All right, exponential right here, when you see ln, that's understood to be e. So that's like saying log base e right here. That's log base e. And don't forget, guys, they have little examples and explanations and stuff over here. They're pretty good. They're not bad at all. This one you can do in the calculator or Desmos. Here we go. So here's one right here. There's a log on one side, not on the other. There's a variable within either the log or the argument. So that means I have to tippy tails. 10 to the negative 2 power equals x. That's it. And you have to say what 10 to the negative 2 power is. Ta-da. Same here. Tippy tails, 64 to the 1/2 power equals blah. You just have to say what it is. Alrighty, let's get one just a little bit more. Here we go. On this one right here, you're still tippy tails because there's one log on one side. You're still doing tippy tails. 3 to the 2nd power equals 2x minus 6. And then you just solve it. That's it. Solving a regular problem then. All right? This one is expanding. Use your log properties. Okay.